Hello everyone. Today I wanted to ask you a question. Have you ever imagined how it would be to have some kind of supervision that would allow you to see any molecules around us? It would provide multitude of practical applications and improve our everyday lives, because now we could see if the air is clean or water safe to drink, and even if the food we eat has harmful pesticides in it. In my thesis, I'm trying to move us closer to this dream, and let me tell you how. Interestingly, in each molecule, the constituent atoms vibrate with specific frequencies, which are determined by the chemical bonds around them. Therefore, the combined vibrational spectra form so-called chemical fingerprints, which carries the intrinsic information about each chemical. And strikingly, this information can be accessed by looking at the molecule interaction with infrared light. And this method is known as infrared spectroscopy. Although IR spectroscopy is a well-established method, it is fundamentally limited by the low sensitivity, which arises from the huge mismatch between the tiny molecule size and the large infrared light wavelength size. So you can compare these measurements to looking at big ocean wave passing over a tiny grain of sand and then measuring how much this wave has attenuated. Therefore, to be able to detect tiny amounts of chemicals, we need to use big, bulky, and expensive equipment, which are limited for practical use. In my thesis, I'm trying to overcome these limitations by employing the power of nanophotonics. Specifically, I developed these metasurfaces, which are made of carefully engineered nanoantennas that tightly confines the light in nanoscale volumes, therefore bridging the gap between the molecule and wavelength size. Besides, it traps the light and allows it to interact with the surface-bound molecules, therefore providing strong and chemically specific signals. We demonstrated that with this approach, we can detect trace amounts of various chemicals, like polymers, pesticides, and even DNA. Besides, it can be implemented with low-cost light sources and detectors into miniaturized sensors, ideally suited for point-of-care applications in fields like environmental monitoring, chemical industry, smart home solutions, and even personalized medicine. And I hope that with this work, we will bring us closer to the dream of seeing molecules around us.